Welcome back, ladies and gents, to the second part of the chapter on derivatives. I hope you are well and that you have enjoyed the first part. Let's review our main finding, what we did in the first video on derivatives. We actually came up with a very powerful formula, yes, that the slope of the tangent line, which we denote as f prime. Those actually are known as what? The derivative, exactly. So the derivative, denoted as f prime, is, well, an extension of the previous chapter, really, because it's a limit. And it's the limit as h goes to 0 of f of x plus h minus f of x all over h. So why don't we actually do another example on how this formula can actually be used to calculate precisely that object we call the derivative, which means really the slope of the tangent line of a graph at a point. So what? Calculate that. So calculate the slope of the tangent line to the graph of f of x is equal to, what shall we pick? Let's pick something that we know how to sketch well. F of x is equal to root x at the point x equals 4. Let's take a nice number because the root of 4 is actually 2. So before we actually dwell deep into the calculations, let us show what we are going to obtain. Set of axes. Here's my x and my y. What is the graph of y is equal to root x? A very well-known formula that we have reviewed in the videos. Looks like this. Yes? Y is equal to root of x. And the point x is equal to 4 is about here, let's say. And what we want is to actually figure out what is the slope of the line that would actually be just tangent, that would just touch the graph at that very point. So I'm going to try to see if I can actually draw a nice tangent line, something that actually just touches the graph. Not very straight, but you get the idea. So what we want here is basically the slope of that line. So we want to know what is the slope of this. I remind you of the advancement that we are actually achieving here from high school, because in high school, in order to get the slope of a line, you needed 2 points. Here, we're actually only going to be needing 1 point, namely the point 4, comma what? What's the y value here? Well, yeah, put it into the equation y is equal to root x, so the root of 4 is 2. Okay, so let us see if we can figure this out. Now, what is the slope of the tangent line? The slope of the tangent line is given by this formula. The slope of the tangent line is f prime, this is notation, and it is the limit as h approaches 0 of f of x plus h minus f of x over h. All right, let us write this down. Let's first start with f of x. What do we know f of x to be? F of x is root x. Okay, I need to replace something for f of x plus h. What can I replace f of x plus h with? Well, f of x is root x. F of x plus h has to be the root of x plus h. And this is how this computation begins. Fx plus h minus fx over h. Please notice that if you actually replace h by 0, in other words, if you do a cheat on this, what are we going to get? If we do a cheat on this, well, replace h by 0. X plus 0, that's x. Root x minus root x over, replace h by 0 downstairs. We know this too well, right? This is indeterminate, meaning we do not know what it is. We're going to have to find a way out of 0 over 0. And if you are thinking about the conjugate because you have roots, if you're thinking about rationalization, you're thinking along the right lines. So we're going to use the conjugate of the numerator in order to try to see if we can remove the 0 over 0. That's our target, right? In the limit, if we get an answer, we get an answer. Hallelujah. But if we get 0 over 0, we need to actually come up with more work. So we want to multiply by the conjugate. What is going to be the conjugate of this guy? The same thing, but with a plus in between the roots. All right. So we've done this before. Not a very difficult situation. So a plus in between those two, and the same thing up and down. We're going to cut to the chase of the algebra here because we know pretty well how this works. So we're going to have here h times the root of x plus h plus root x. And what do we have in the numerator? All right, root x plus h times root x plus h. What is that? Clearly, x plus h. Now, we know very well that if we do the conjugate correctly, the two middle terms will go. So I'm not even going to put them down. I'm going to go with root x times root x with a minus. So that's minus x. Good. So those two are gone. Those x's in the numerator, they are gone. I am left with this. Root of x plus h plus the root of x. Clearly, and without any doubt, these two are gone. And then I can cheat and then get what? 1 over, replacing h by 0, x plus 0 is x, so that's root x plus root x. In other words, 1 over 2 root x. What is that expression? That corresponds to the slope of the tangent line at any point x. Okay? So 1 over 2 root x, whatever the x you replace in there, you're going to get the slope of the tangent line. We are given one specific x here, and this x is equal to 4. So I'm running out of space here. I'm going to finish the problem over here. So the slope of the tangent line, is 1 over 2 root x. But what is x? X is 4 from here, right? So the answer to the problem, what is the slope of the red line, the line that is tangent to the graph of root x? It is 1/4. So once again, I hope you appreciate the fact that we've been able to calculate the slope of a line using only 1 point. But that's because it's a very special type of line. Yes, it's a tangent line, not any ordinary line, a line that really only touches the graph at 1 point. That's what we mean by a tangent line. So locally, there's only 1 point of contact between the line and the curve that it is grazing. Good. All right, that was a good example. Perhaps we can build a little bit on this, but we need the space, so let's erase this in 2, 1, 0. So example 3 is actually really just a build-up on example 2. Example 3. Find the, okay, here's a key word now. Not the slope of the tangent line, but rather the equation of the tangent line. The equation of the tangent line to the graph. Let's use the same function. To the graph of f of x is equal to root x when x is equal to 4. So you will notice that this is very similar to the problem before. There's one word that actually changes, a pretty important word. This time we want not only the slope, but we would like to have the full-fledged equation. In other words, what are we looking for? What are we looking for? We're looking for the equation of a line, ladies and gents. So we're looking for y is equal to ax plus b. You know very well that this has two unknowns, the slope and the y-intercept, right? So it's the same curve as before. So here's your root x. Whee! So here's your x-axis. Y is equal to root x. This is your y. And this is the point 4, 2, at which there is a tangent line. So now we're not satisfied with having only the slope of that line. We want the full-fledged equation. Piece of cake, right? Because we already have the slope. So from example 2, the slope is equal to 1/4. So because we know that this point right here on the graph is the point 4, remember what it was? Yeah, you put it in. Root of 4 is 2. That's the y value when x is 4. So because we know this, it's a piece of cake actually to just figure this out, because y is equal to ax plus b. So really y is equal to 1/4 x plus b. But I need a point on the curve, and I do have one. I have 2 here for my y, and I have 4 here for my x. So 1/4 times 4 is 1. Bring it over. B is equal to 1. And that's it. We have our answer. What is the answer to this problem? What is the equation of the line? Answer: y is equal to 1/4 x plus 1. That is the equation of the line. Good? All right, excellent. So let us see if we can erase this in 2, 1, 0 and present you with more or less the same thing, but viewed under a different angle. Okay, so let's call this alternate way to look at the derivative. Alternate way to look at the derivative. Well, basically, how did we obtain the formula that we obtained when we saw the first video on derivative? Remember, we took 2 points apart and we shrunk the distance between the consecutive points until the 2 points were so close to each other, then you could not tell them apart. They were kind of, we used the word indistinguishable. Well, if we have that here, but we change a little bit the parameters of the analysis. So x and y, let us have, I don't know, let's take the same curve as before. It was convenient. Y is equal to root x, once again. Okay? But this time, what I would like to do is basically have here, no, not this, is actually, I'd like to have here a point A, and then further away, a point x. Yeah? So that if I go to the curve, I get 2 points on the curve whose coordinates are what? This would be a and f of a, right? I could have actually said root a as well, and I will. And this here is x and f of x. So basically, x and y. And then through this, right now, I have what is called a secant line. If I actually write a line that cuts, that's a secant line, it cuts the graph into 2 points. Now, what I want to do is I want to bring that x closer, and closer to a, right? So that when x is actually very, very close to a, I have this. When x is, remember like when we said like h goes to 0 in the previous example, it's kind of the same idea, not kind of, it's the same idea. But this time around, it's basically, I need to redo the graph here. So same graph. But this time, all these markers, too many markers. Now what I have is one point A, and then at this point A, I draw one line. I draw a tangent line like this. When does that happen? It happens when x has actually gotten very, very close to a. This is what's happening when x is actually getting very, very close to a. So what's the situation here? If I have that, then let's go back here. The slope of the line is, of course, the usual delta y over delta x, right? That has not changed like since the days of Descartes. So basically difference of the y's would be f of x minus f of a. Difference of the x's would be x minus a, right? Now notice I didn't put ATG because it's not a tangent line, it cuts through the graph in 2 points, it's a secant line. But here, I really have only 1 point. And how did I go from here to here? Like I did before, I let my x approach a very, very, very close. So now what I have here for this slope, which is really now a tangent line, it is the same thing as before, f of x minus f of a over x minus a, but because those 2 points x and a are so close to each other, then I need the limit. But what limit is this? Well, yeah, it's the limit as x gets close to a. And that, ladies and gentlemen, is just another way to express the derivative. Except that this time we introduced in the plan the very point A at which we want to take the tangent line. So we call this f prime at A. I'm going to put that in a different color because it's kind of remarkable. It is the derivative of the function at a point A. It already includes the point that we want to consider at which we have a tangent line. Yes? So that's kind of a interesting, different formula, but it speaks of the same reality. It talks about the same thing. It's still the derivative, but this time, instead of being like the general derivative, it's the derivative of f of x at a point. What point is that? At the point x is equal to a. Good. Let's actually show an example on how this formula works. But first we have to clear that very small whiteboard in 2, 1, 0. All right. So what would that be? Example 4, I guess. So example 4. Use the derivative at a point. Let's put that between quotation marks. Use the derivative at a point formula to calculate the slope of the tangent line. Let's do the same problem as before because we know the answer. The slope of a line tangent to the graph of f of x equals root x at x equals 4. Okay, we've done this problem before. We've done this problem in this video. We know the answer is a quarter. I just want to illustrate how this different formula can actually just show us how to get to the same answer in a different way. So, f prime at a is the limit as x approaches a of f of x minus f of a over x minus a. Now, what's my point A? What is my point A? The point on the graph at which I want the tangent line is here. That's the point of interest for us in this graph. So basically, this boils down to the limit as x approaches 4 of f of x minus f of 4 over x minus 4. That's going to be the limit as x approaches 4. The rest is really like algebraic. What is f of x in this example? Right there, root x minus, what is f of 4? Put 4 in the root of 4. Over x minus 4. I'm not going to do it, but you can do it in your head. It's very easy. If you were to cheat at that point, what would you get? What would you get? Well, we'll put the 4 in there. Root of 4 is 2. 2 minus 2, 0. You would get 0 over 0. Meaning, we need to get out of this situation by doing what? Of course, there is a root. So, when you notice the root, you know that you have to use the conjugate. So that's the limit as x approaches 4. We're not going to expand the bottom because the bottom parts are not conjugates of one another. But the top we will. So vamos. Root x times root x. That is x. The middle terms cancel. And then I'm going to get minus 4. Oh. Now I'm going to get x plus 2 root x minus 2 root x minus 4. And of course, this goes away. And we are left with the limit as x approaches 4 of just this 1 over the root of x plus 2. So that's 1 over the root of 4 plus 2 when you cheat. And that's 2 plus 2 downstairs. And it's the same answer we got from the other approach. It's just perhaps a little more direct if you want the equation of the tangent line at a point, simply because it involves the existence of that very point. You don't really have to replace it afterwards like we did in the previous one. Good? All right. Okay, do we have time for another quick example? So basically, I showed you this to show you that, great vocabulary, teacher. I actually showed you this because you should be aware that there are two ways to look at the derivative. That being said, we in this class are really going to focus on this one. For us, this will be the one we use the most often. So the one we saw in the first video on derivative. So the one with the h, the limit as h goes to 0 of f of x plus h minus f of x all over h. Lovely, 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 lovely. So, example 5, I guess. Lots of examples today, which is good. We need to see this in action. Calculate the derivative. Calculate the derivative of this function. I'm not going to involve a point. I just want the general formula. Once I have the general formula, I can plug in any point that I want, and I'll get the slope of the tangent line to the graph at that point. So what are we doing here? We're going to calculate the derivative, which will give us, like I said, something very general. So what is f prime? It's going to be the limit as h goes to 0 of, vamos, f of x plus h. Well, you know what? Why don't we start with f of x? Why don't we start with f of x? It's easy. It's given f of x is 1 over x. Now, let's be careful about this. What is f of x plus h? Well, I know I need to replace x with x plus h. Here we are. And once again, if I replaced h by 0, what would I get? X plus 0 is x. 1 over x minus 1 over x is 0 over 0, the usual shebang. I can't have this as an answer. I got to do something. I want to do this algebraically. What do you think is going to be the algebraic tool that I need? Well, fraction minus a fraction. Common denominator is the ticket, indubitably. So limit as h goes to 0. All this over h. What is my common denominator for the numerator? Well, it's simply the product of these two denominators. So x plus h times x. Just multiply the two. And then crisscross. This times dot is x. This times dot is x plus h. Be careful with the brackets here because you have a negative sign. It's actually going to change all the signs inside the bracket. So limit as h goes to 0. What do we got? H here. And on top, what do we have? Let's open the brackets. X minus h. The x's will cancel. I will just get minus h over x plus h times x. This is awkwardly written. We can do better. We can do better by flipping the h downstairs. So this is minus h over x plus h times x, and then division by x means multiplication by what? Division by h means multiplication by 1 over h, which gives us what we expected to happen, the cancellation of the h's, and that's a limit as h goes to 0 of minus 1 over x plus h times x. We're now ready to cheat again. And the answer to this problem is minus 1 over x plus h. H goes to 0, so that's just x. And x times x is x squared. And that is the derivative of the function 1 over x through what we called the limit definition of the derivative. Limit definition of the derivative. Okay, we're already into like 28 minutes. We're going to stop here, but we are going to use this very result as the first thing we do on the next video on derivatives. In the meantime, you take care of yourself. See you soon.